Rachel. I'm the Science Kid here, and let me show you a little experiment. So right here, I have a necklace I got from the STEM for All Gala. You can watch the full video. But anyway, I will turn it on like this and bring it up close so you can see that all of the colors are in the same circle. See? You're getting very sleepy. Just kidding. Now, watch what happens when I spin it. Note that all the colors are still in the same circle. Can you see it? All of the colors have somehow been spread out to be individual and in different positions. Now, let me show you why this works. Let me draw a drawing of your eye. Here is your eye, but poorly drawn. And here's your brain. So, when you see me spinning that thing, it will have changed colors during the duration of its spin. Let's say right here, it is blue. It will be blue 2 times, red 2 times, and white 2 times. So, when your brain detects the blue, it will take some time. Let's say it takes like a nanosecond to get to your eye. Then your eye will take some time to send that signal to your brain. Then your brain will take some time thinking and saying, hey, it is now blue. But what you don't know is that during all of this time, which will be 1 ns, then let's say here also takes 1 ns, so that would be 2 ns, and then your brain takes about 100 nanoseconds, so that would be 100 nanoseconds to process all that information. So that's 102 nanoseconds. But by the time that your brain processes that it is red, it has changed to blue. And by the time your brain processes that it is blue, it will have changed to red. And then now your brain will have to change. Your brain is still processing that it is blue when it has changed to red. So now it is detecting that it is red. I don't know if you can see it since that marker is kind of dried out. But anyway, 1 nanosecond, 1 nanosecond, 100 nanoseconds. And your brain was now slowly erasing that blue picture, so it's still kind of there, while also changing it to red. And then by the time it's done that, it is now white. So now your brain is erasing that red picture and also still erasing that blue picture while changing it to white. Now keep in mind that it is changing positions. So your brain detects the blue to be here, and that picture is kind of lingering while it sees the red, and that it has changed to here. And while it's seeing that red and the blue is lingering, it's already changed to white, which is all the way over here. So it's now trying to process that while these two are still lingering in your mind. Then it's changed to blue, so on and so on, until we get a result of all of the colors lingering in their different positions, when really it's all just the same thing in the same circle. Now, you may have also also seen this. If I bring the light here and then remove it, you may see that light lingering on for a little bit in your brain. And when you close your eyes, you might see an inverted color version of that light. So it might be black, green, whatever you see. And this is called an inverted afterimage. This is thought of as scientists to be how when you see that color and you're seeing all of like maybe green, let's say that I change it to blue. Now when you're looking at that, when you're looking at the blue, you can see all that blue and your blue rods and cones are being activated. So one moment. But your blue rods and cones are being activated, meaning that all of those blue rods and cones are being constantly stimulated for an extended period of time. I will draw blue lines for your cones. So see, all of those blues are being stimulated for a long time. This causes them to get kind of tired. So this is your cone right now. And they get kind of exhausted. So when you look at a white background, the blue cones are kind of not picking up all of that blue information from red, green, and blue, which is all in white. So instead, what you see is instead of just a white background, you see a red version of this, or a reddish-green version of this. So you should be seeing white, but really, you're seeing red. And that is because the blue cones have gotten tired and are now catching up on that mist relaxation, causing that red afterimage to slowly disappear until all you see is another white background. So this is important because it's one of the reasons why when you close your eyes, you see those flashes of light and color sometimes. It could be afterimage of what you've looked at recently, or it can just be random stimulations of your rods. But nonetheless, your rods and your cones are all very special in their own way, and they all cause you to be able to see this cool thing. You can see that it's only like flashes of blue. But last but not least, is this bad? Is this good? Should I be worried about afterimages? Don't worry. Afterimages in your eyes are natural. It's just your rods and your cones getting a little tired. And it's also your brain being kind of laggy with your vision. Anyway, bye, and keep on